Okay, I don't have a lot of time. Now I have to be somewhere like an hour. So I'm gonna do this as quick as possible. All right, update. Let's see. All right, first update. Um, is I didn't put it in here. Why didn't I put it in here? Let me go get this. Put it in here. I finished over the weekend my portfolio. So now that's up and running, which is freaking amazing. This is what it looks like. Dope. It took a long time, especially trying to embed this video of just code running took far longer than it should have. But overall, like I'm actually pretty. I had an AI image of this. Let's see if I can get it. It was gonna be this, but I don't know. I felt like this was so. It was from what's the model? Gemini Banana. And I actually thought this was pretty. I like the graphic. I think it's growing on me, but still, I don't know. I just feel like it's, and that doesn't even say basketball. That says, I didn't even notice that. I don't know what that says. But ban read ball, right? Can I crop that? Cause I would just crop that. Can I resize it? Oh, I don't know what this would be. Pixels. It'd be the height. Right now I'm like 700. What does that look like? Okay, guess they're not gonna show me. The other thing I could do is just take a screenshot. But anyways, that's irrelevant. That's what I was gonna put here. But this is a new project, which will be where the other project I didn't put on here was the CC Me Planner, which is great because instead of trying to reinvent the wheel, which I will not do, I was able to basically just adapt Aiden's. So that'll help a lot because a lot of the YouTube videos that I wanted to follow, they were just going in such a different direction that I was like, by the time that I finish a video, I basically made a banking app. And now the front end and the back end is adapted towards something that I already just have to completely redo it. Like, is this for practice or is production, you know? So I wasn't really feeling that. So that's that, but that's not what this is about. That's what I will start. I have a meeting at like 4:30. I will begin this once I come back from the meeting. Right now, though, I'm gonna finish my notes. I read through, that's what this is, working and analyzing, but I completed this entire video. I didn't completely do the code, so I should probably finish that. But also, this is without TensorFlow or PyTorch. Let me see. I think TensorFlow. Which one is this one? This is the one by Google. No, then it's PyTorch. PyTorch is what I'll be choosing to utilize. So I'll do some, and there's this as well. Yeah, a lot to do. So that's what we'll be using here. And then I honestly have no clue. I'm still in the interviewing and knowledge obtaining phase. Like I still have to learn about frequencies for hearing aids. I still have to learn about the different types of hearing aids. There's cochlear, in ear. There's a lot. But I've been talking to a lot of audiologists at like nearby universities, my own university. So that I think that's like a 1 to 2 year project. I don't know why I thought that was gonna take a couple of months. I still have to figure out how I'm gonna implement that. Like, am I gonna use an app that connects to, like, how is that gonna work? And how is that different from any other app? I don't know. And then the project that isn't on here would be the CC Me planner. So I should probably put that on here at some point. I will put this on here once I get like a like this. Once I get something like this, I'll screenshot it, put it on there. But for the time being, I also need to try and see if I can this is also a good opportunity. I'm everywhere, but this is also a good opportunity. Like 4 minutes before I start. This is also a good opportunity for me to learn TypeScript. Which is what I plan to do here, is to learn TypeScript in this. Yeah, there's a lot to do. But I just figured it'd be easier and better for me to learn TypeScript, continue learning JavaScript, etc, while working on you know what I'm saying? Like working on something. Okay. That's another thing. I'm gonna have to kind of brainstorm. I'm gonna have to brainstorm some logos. See what I'm thinking. Yeah, I'm just gonna get a proxy for what's all in here. Some PNGs. I think the community college this is aimed at should have that. And I believe there's some per the README, there's some packages that I don't have that I actually do need to install before. Yeah, I think I have to get both of these plugins. I don't know if I have React. I know I have Node. I don't know if I have Vite. I remember doing that last project and it didn't use Vite. We used some. That's why the project didn't work, that to-do list project, because we didn't choose Vite. We just went with whatever the tutorial was. Yeah, so I'm gonna have to do some installations. Vite config. Yeah. Okay, that's fine. And then I'll also have to look into. This might just take me to the same document. What time's that? I've got a minute. This might also take me to the same document as well. But that's fine. Okay, so yeah, I kind of know. Oh, let me do that. I think that's why a lot of this is giving an error. Yeah, packages installed. So I just don't have the correct packages. So all of these should give an error, which luckily for me they do. Okay, hooks. Boom, boom, boom. use container, infinite scroll height, load more when the user scrolls to the bottom within the threshold, use an effect. This is for on mobile. Okay, library. I also need to be able to course ID, course gen eds, error, return the data, subjects, getting user ID, user semesters, user management. We're taking their email address, first name, last name. Try and get an existing user. But if there is no existing user, then we're gonna create a user. User ID, email, given, first name, last name. If it provides an error, tell them it's an error and return them to the new user page. If we get a fetch error, return existing user, unexpected error, and get or create user. Semester plans. Okay. And then pages, plan. I need, and then here's Vite, main, index. Okay, that's fine. Now let me return to what? Oh, my bad. Okay, let's return here. I will. I will probably. Yeah, there's the softmax. There's also the ReLU, the rectilinear function, which I think. Where's the rectilinear function? Where do we definitely apply that? Yeah. Activation layer functions. Yeah. When x is greater than 0, we just return whatever x is, and when x is less than or equal to 0, we return 0. Ton h or ton, and then the sigmoids, and there's the rectilinear unit, active layer functions. I don't know if I want to finish this because his actually had a good bit of errors. I mean, it wasn't his fault. It was like small stuff like functions and what's the word for syntax errors. But I might, let me see. Let me see. Can I do a I always go through like tutorial hell and it pisses me off. Every time I go through like tutorial hell, it pisses me off. I also still have those problems to do from the algorithms book that would have been due today. Why is this taking so long? Oh, it's just a link because I just clicked on Carnegie Mellon and it worked. Interesting. I can definitely see more universities heading in the same way of MIT OCW. Why does this name sound familiar? Rita. That name sounds so familiar. Silent. I don't know. Oh yeah, Piazza. I have a Piazza account for a physics thing. grading, introduction, neural nets. All right, I'm just gonna start. So I read, what did I read yesterday night? I read the introduction. Well, I basically read everything up to page 12, so maybe I'd say a little bit over 15. Probably a little bit over 20 pages. Now I'm just gonna go back and kind of write notes over what I wrote or what I highlighted. Because I highlighted, I didn't really feel the need to write. I was watching a football game. That's kind of lazy. This neural nets from scratch. I'll probably end the code here. I get the gist. I mean, I don't have a. I gotta get a bookmark. Will be ending. What is it? Will be ending code here. Yeah, let's but actually, no, I won't. I can just. You know what? Why not? Let's.
Hi everyone, my name is Samson.
Oh, hi Samson. I think. Let me figure out if I can.
See.
Hello. I don't know why I made that so big. This should probably be like this, like this. Turn this on. I think I have this as one big thing. Yeah, X-train. I think I'm a bit further. Oh wait, no, where are we at? Data, we've put the data in an array. We've defined m number of columns and we've asked for data shape. We've done a random shuffle of the data. Now the developer data, and we've transposed this. Oh, so this isn't the, we've already inputted the training data, or we should have. No, now we're doing the training data. Okay, this is the test data. Should be. Maybe it isn't. Okay, now I kind of have to pay attention because this is where he begins to talk about. Oh wait, here's the Kaggle thing with all the code. What? I'm a duck. That's fun. All right, let's see here. This is more accuracy of 93%. Use pandas, params. If I modulus 10 is equal to 0, we'll print iteration every 10th iteration. Gradient descent. Runtime error accuracy not improving due to softmax implementation. Working solution. Nobody just wants to write out the full code. Let me see. Actually, I could just do this. I don't even know why I did that. Okay. Got it. All right. Mm, where? Okay. Where am I supposed to be? This isn't it. This isn't where I'm supposed to be. Okay, that's fine. We'll just have to use, I'll just use this one. This one will give me a accuracy of 93%, and that's fine. We'll just figure it out the rest of the way. So, divided by 255, and it'll be fine. New data, I'll just figure out the syntax and whatever the hell's going on. Okay, data equals np.array. Made the data into an array and fed it into the variable data. Boom. M comma n equals data shapes, M columns, and n features. That's what it was. N features. Boom. np dot random shuffle, shuffling the data around before splitting it. I think this is a very important step. I should probably put that somewhere. I feel like this is a very important step not to forget. Okay, then we have data dev, data and then we've transposed it. Okay, now what I will include also, there's 1,000 rows, div and t equals transposed vertical. I think I know what transpose means, so I don't have to put transpose to vertical. Transposition means to flip anyways. Okay, so I said all that because I just wanted to make room to write 785 by 1,000. 785 by 1,000. Okay, we have y dev equals data dev 0. Okay, and then the note here is that we have, I'm getting lost. Oh my gosh. Okay, we have 1,000 to comma vector. Oh, this is 785, but this one's 784. How does that work? Why is this 784? I'm intrigued. Whenever I'm about to ask a question, even in my notes, like I keep the syntax, physical syntax, the same. I always put a question mark before my actual question. Why is, I mean, I get it, 28 by 28, right? So 28 by 28, that's 784. Why are we doing, what is this? Transposing. This is the layers plus 1. Does that come from, where did we do a plus 1 at? We did a plus 1 somewhere too. Here. Columns and n features of data plus 1. I think this is where it's coming from. So then I guess we go back to 784. And 9. I think I understand the answer, but just in case, I'll ponder this and think about this for a little bit. I'll make this bold. You can't really do bold. Make it red. Oh, it makes everything red. Huh. I'll just have to somehow remember. That's interesting. I don't know how I'm gonna do that. It's fine, whatever. Okay, that's xdev, and then we're setting x underscore dev to be equal to x underscore dev divided by 255. What is 255? And the dot. That period is important. I'm not sure why. Why is the period important in deep learning? What the frick does that mean? That's a critical learning period. No, why is the period? Ah, the dot product. Ah, that's right, that's right, that's right, that's right, that's right. That's right. Okay, that's good. Here, represents. So it's the dot product. I might put this in all caps so that I'm. All right, that's great actually. That's test data. Wait, yeah, that's test data. Wait, oh my gosh. Can I zoom this in? I'm so blind. Okay. All right, now we're good. Now we're good. All right, so this represents the dot product. We've got that. Okay, data train equals heated 2000. This will be the training data and we're transposing it. Oh, so we just went from 1,000 columns? Or what is this, 1,000 nodes? What is this? What is this right here? This is, N is the number of features. So this is I'm guessing this is 2,000 columns, which we've turned into layers. So instead of 1,000, we're doing 2,000 on the training data, 1,000 on the test. Whoa. No, we're not. Am I tripping? No, I'm good. I'm not tripping. But something is off here. Yeah, I just skipped a whole row. Yeah, these look insanely similar, but they're not. I'm missing a whole. There should be. That's data dev. Yeah, there should be a whole data test line here where data is in this array from 1,000 to 2,000. That's what I'm forgetting. And then we're going to transpose that, and this represents 785, which is the columns or n features of data plus 1. So 784. Okay, and then we'll have y underscore test, x underscore test, x underscore test again. I feel like I'm tripping now. 0, 1 to n, x dev, test. Okay, no, I'm not tripping. So now the y test is going to be equal to the data underscore test of 0. I'll just keep it like that for now. X is going to be equal to the data underscore test of 1 to the number of features. And then x underscore test is going to be equal to x underscore test by 255 with the dot product. Okay. Okay, now we get into two row, basically from 2,000. Well, if this was a column, or if these were columns, but now columns. This is gonna go from 2,000 to basically the end of the columns. Is what I'm. So what is dev versus test versus train? Dev. Oh, I could just look it up in here, can't I? It's gotta be something in like the back of this book, right? Like a what do they call it? An index? Yeah. Okay. Train. ABC. Okay. Data representation, data set representation, deep learning, dot product. Oh, I'm about to learn about it, I think. That's what it's saying here. Because, okay, I don't see dev anywhere in here in the D. So I'm assuming it's gonna, my next thing is gonna be training and test set. Whoa. No way. Okay. Okay, here we go. Sensors. Training error. Transpose. Yeah. See, that's in like, yeah. Okay. I think it's gonna, I'm gonna skip over that for now. Just like dev versus test versus training. The frick is dev? Training, dev, development, validation, and test set. Okay, the training set is to teach the model. Yes, I got that. What the frick is a dev set? To tune hyperparameters and select the best model. And then the test set is to evaluate. Oh, okay, okay, okay. Direct learning, forward and backwards propagation. Indirect influence used strictly for evaluation. No influence completely locked away till the end. Textbook exercises and homework or practice quiz. All right. So the dev, I'm also gonna, because that's the order this goes in, I may move the training. No, that's interesting then. So why are we training from 2000 to beyond? I guess we're using the beginning to tune the parameters, the end to train, and then the middle will be what we test on. That's so interesting. Why? I mean, I think I get it, but like, why? Hmm. Okay, cool. I'll think about that. I don't know if that might be an interesting take. That's almost like doing the, like you're tutoring someone and you tutor them on the first 5 questions and then the last 5. And then once you let them loose to be independent, they do the middle 5. And the middle 5 is kind of like a culmination, like a sweet spot. So that they're not too hard for them because you've done the hard ones with them, and they're not too easy because you've done the easy ones. I get it, just it's interesting. Very interesting. All right, next block of code. I also need to separate these by blocks of code too at some point. Then we're gonna do define this function called init params that takes in hidden size is equal to 10, and then it will say weight 1, wait, oh, bias 1, forgot. Ooh, weight 2, and then it'll be bias 2, and then it'll return weight 1, bias 1, weight 2, bias 2. Okay, so weight 1 will be, see, this is where in the video he was like he shouldn't have used ran in. So the fact that this guy used ran in is holy crap. What the hell? Oh, for propagation. Given these predictions, get predictions. Predictions is this to 10. Y test, shape of predictions, shape of Y test, get the accuracy given these 2 parameters. Oh, he's just created a bunch of functions basically. For lambda and lambdas, print training, F training with lambda. This is so interesting. What is the purpose of him using a lambda function? What the frick is a lambda function? Anonymous function defined without using the name can take any number of organizations. They return 1 off. The argument x. So why is he using a lambda function? This Can even use a lambda function. Function object, the keyword, the argument, and the online expression. So what was his lambda online expression? Okay, he defined, find the best lambda. Interesting. Yeah, he did a good bit. Test these predictions. Current image display. He did a good bit. Oh, I've written functions to select the number of neurons for a hidden layer and also implement regularization to reduce the loss, but this had low impact than the number of neurons. So he had a greater output, or he had a better, what's it called? He had a greater, what's the word called? Dang, what is the word called? He got more bang for his buck by selecting the number of neurons for the hidden layer than the regularization. The regularization probably worked, but in terms of what worked better, the number of neurons for sure. Okay, that's fine. Oh, and then this is kind of what the, what's it called? Unless he edited this. Has he edited this version 5 of 14? Oh. Well, let's see what this version looks like. He commented. Oh, and then these are the predictions and, oh, okay. So this is the, but he commented all of this out? Oh, there's the rectilinear. Oh, wait, I'm on version 1. Okay, yeah. And then I'm assuming this is, we should see some sort of lambda function, and that would have let me know that this is the most recent one. Oh, I see no lambda. Maybe he alternated it as well. So maybe, oh, that's right, because this is quicker. I mean, this one's more efficient. We're looking for the one that ran in what, like 2 minutes and I can't even. Which one are we looking at? For the one that ran in, is it 2 minutes and? We're basically looking for this one. But by golly. How do we know which one it is? We'll have to go through until we find a lambda function. Or, I mean, we could just look at the, whatever. Whatever. Yeah, because see, he went into params. This is because this is, let me push this over a bit and, oh, I didn't mean to do that. Take that out. Please move this. Move this. I'm gonna get triggered. Please move this. Move this. Oh. Get this out the way. Thank you. Can I move this? Can I get this? Okay, I kind of need to compare them side by side. Cause this is, I feel, okay, whatever. I keep saying okay, and then trying to find something and then get, like, peeved. How do I know? This received 93% accuracy. Great. But what? Posted on version 1 of 1. So does that mean this was his first version? Had to have been. Yeah, it was this version, wasn't it? But he's missing his test set here. Okay. Oh my gosh. Love that for you. Oh, this is what's pinned? Okay, yeah. I think this is what I'm looking at. Okay, this one ran 2 minutes and 5 seconds, and then he was able to get the runtime down to a minute, which is actually really good. Of course, he shaved off a whole minute. Okay, I'm gonna continue with this one, and then we'll move forward. I've got like 30 minutes for my meeting. Okay, I'm gonna put this over so speed run. All right, weight 1 will be characterized by function random rand in of the hidden size, and we'll do that times np to the square root of 2 divided by 74. And this is how do you spell rectilinear? I think it's well, we'll just type in ReLU. There's the ReLU equation, but then there's also the sigmoid activation function. But I don't think he used that. What else is there? What am I thinking of? Logistic regression? No. Layer of neurons. W times P plus B. No. Prediction, bias, weight, feature. The neuron activation function. Weight A, weight B, weight C. Input A times weight A. Didn't mean to click on that, but here we are. This is summation. Prevents overflow. So he used the rectilinear function, then the sigmoid function, then the softmax. Then he used forward propagation. Then he took the derivative. What is one hot? one-hot encoding, pre-processing technique that covers categorical data into binary format. Oh yeah. So then what are we gonna use? I guess it just, because encoding means, yes, like we're taking it from how we view it into a format that the computer can understand. So I'm guessing we're just gonna, what's the opposite of the encoding here? NP zeros, return one hot. So would we just feed it back through this to get our answer? Oh yeah, because look, here's backwards propagation. I think that's why we're taking, is that why we're taking the derivative? I think so. I think so. Okay. That's the other thing about like learning as you go. We have to question literally everything. Question everything. Okay. This one is basically the same thing, so I'm just gonna copy and paste. Or wait two. It's a bit different. It's np random.randin, but it's gonna be 10, and then it'll be the hidden size. And then we're taking the square root of 2 divided by the hidden size again. And the bias, they're pretty much kind of match up. NP zeros of the size, comma, 1. This one's going to be 10 to 1. Okay, and then that's what we'll return. And then now we're going to define the rectilinear function, otherwise known as ReLU. We're going to define that for parameter z, capital Z. And this will be, we're going to just return the maximum, or the maximum, the parameter in 0. And then we'll have a sigmoid, which takes in the same parameter 0. And it'll return, it's going to return 1 divided by, oh, this is the what's it called? 1 divided by 1 plus np of the exponent of a negative z. Yeah, this is basically that. Where's that sigmoid function? That's rectilinear. Where's the sigmoid function? We just looked at it. Sigmoid function. It's basically this. But instead of 1 plus e to the negative x, it's e to the negative z. Okay, that's fine. Okay. And then we're defining the softmax. Softmax function. We are in z is a parameter, and this is to prevent overflow. And we'll have the underscore shift equals c minus np dot to max of z, and the max is going to be equal to 0. And then we're equal to true. No clue what that means. Gotta look that up. And then the exponent of z is going to be equal to np dot the exponent of, or e to the power of the underscore. And then we will return the sum of the exponent of z, big Z, the x equals to 0, and not sure what that whole function means. Oh, just kidding. The sum. Oh, okay, okay. The sum from. Oh, this is basically what we just did. The summation of all of this. So what is the z shift is z minus. That's the sigmoid function, 1 plus the exponent. But the softmax function is the exponent x sub I, which for us would have been z shift. And then we're doing that over the summation of basically z shift. Okay, that makes sense. We're just implementing these functions. We're implementing this, which I think I already have on here, over here. Yeah, this is basically what we just did. Okay, that makes sense. Okay, now we're gonna define forward propagation. Oh, yeah. Forward prop. And I'm just gonna take in the parameters and x. And we'll give it z1, a1, z2, a2, z1, a1, z2. Okay, z1 is gonna have the dot product between the weight and x plus the bias. And then a1 will have the rectilinear function. Z1. Whoops. Z2 will have same thing, but it will be the weight and the dot product of that with bias 2. And then it will be the softmax. I can't remember. I think A2 is layer 2. No? Or is Z2 layer 2? If I see the graphic, I'll remember. He wrote like a whole graphic about it. A naught. I think this is. No, I think this is the Z naught, but this is Z1, and we get Z1 from calculating the weight associated with this, and the bias. And then, but is this?
It's just equals x.
And then there's the derivatives. My head is like 1,000. I don't like having my hair up, to be honest, but it looks like a pig's nest. Or a pig's nest. A pig's. Where do pigs? A pig's pen? What? A pig's pen? A pigsty? I think that's it, a pigsty. Right? A pigsty? It doesn't look good. Okay. Okay, that's forward propagation. Oh, and then we gotta do the return. And then do my flip. Z1, A1, Z2, A2. Basically, I'm just gonna. Oh, just kidding. Now we're gonna. Which is gonna be not my. Oh, I'm sorry. I'm getting like I'm confused on the oh. Oh. Oh, so this is just what we're doing to this. So it's gonna be np dot zeros. We're gonna take in the size, or y dot product the size. I gotta make those capital. Max. And then add one. Interesting. 1_hot. And then we'll arrange it such that y dot size is equal to 1. I think I remember seeing this in the math too. And then this is going to be equal to 1 hot y dot transpose this, and then we'll return that. Okay. Whoops. And then we're going to define backward prop. And I'm going to, so it's going to take in all of these parameters, and then we'll have n is equal to something, the derivative, that's what these stand for now. Now we're taking the derivative of z2, now we're taking the derivative of z2, and the derivative of the bias. And then we're taking the derivative of z1, taking the derivative of weight 1, and then we're taking the derivative of bias 1. This is basically this section over here, right? dz2, dw2, yeah, it's 1 over m. So I think, how are they gonna do that? 1 over m. M equals x dot product of the shape. Okay, so x. Is that what that means? I think so. Let me make sure. What is this? What does this? I think that's what it means though, but I just want to make sure. It extracts the size of the second dimension columns from a matrix array named x and stores it in this variable. Shape returns a tuple representing the dimensions of an array. Because Python uses zero-based indexing, targets the second value. Okay, that's fine. Number of features. N is our number of feature. This is our columns. Okay. A2 is 1 over m multiplied by, yeah, now we're verbatim doing the formula. Transpose. Okay. I'm good with this. Now I can go ahead and copy. I understand what's going on here. And this is the summation. Okay. This is weight 2 transposed. Let me make sure that's the derivative of z1. Transposed weight 2 multiplied by dz2 derivative and multiplied by the rectilinear derivative of z1. Okay. Now, this is where I'm interested to see what Samson's, what is lambda supposed to be? What is he seeing? What is this dw1? 1 over m dz. He just has x being transposed, which is interesting. Same thing. What does it mean to keep dims equal to true? It's another thing. What does that mean? Oops. Let's see. It's a parameter in array processing libraries that preserves the original number of dimensions of an array after reducing, or after a reduction, calculating the mean or the sum. They're usually removed, causing the array to shrink. And ensures the reduced access is left in the result. Okay, so just make sure that we keep the same size that we had already. Okay, define. Now we're going to update the parameters to weight 1. Oh, this is the learning rate, alpha. That's what that is, the learning rate. Yeah. I think this is it. I think this might be word propagation. This is just so that he can get this printed out. Predictions, shape of predictions, find best hidden size, best accuracy, for size and hidden sizes, where hidden sizes is, and then best hidden size, best size with accuracy. So what is that? 4 spaces. And hidden size is equal to the make predictions. Well, what is his? Oh, here's the TensorFlow implementation. Holy moly, that's so short. Dude. It's so small. Wow. That's so funny. How tiny that is. Okay. Okay. Didn't mean to do that. Alright, so boom 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 boom. Where are we at? Okay, now we're gonna update these parameters. This part I do understand. The updating of parameters. I do understand this. Learning rate, we're taking our learning rate and multiplying it by the derivative of the weight, derivative of the bias, derivative of the weight, bias, and then we're just gonna return this. And that's how we update the parameters. Then we're gonna define a function. Can you hear that? They always want to mow when I'm doing stuff. Define, get predictions. Define, get, it's okay, I'm about to end anyways. They can have it. Define, get predictions. Return the argmax. Interesting. Get accuracy, given the parameters of the predictions and why. Why is our output right? And there's gradient descent. Okay, so let me get to here, and then I'm gonna have to. This I understand. Getting predictions, feeding in A2, which I think is our last layer. This is A2. This I understand. Getting accuracy given the predictions and the output, which I do think Y is our output. The model output, to be specific. Okay, now we're defining gradient descent. This is where it's gonna be interesting because what is lambda doing? Why are we putting lamb? Did he put lamb that I don't remember? I don't think I remember him putting lamb. I was about to say, I do remember this. Then the gradient descent. See, he used the parameter x, y, iterations in alpha, which alpha was our learning rate. So this is where the code should stop. Probably about here. Okay. Now we're going to define gradient descent. That's fine. I know how to. Defining gradient descent. I'm actually going to bring this out. Okay, we've defined gradient descent given these parameters, learning rate iterations. Y is lambda equal to 0. Hidden size we've set equal to 10. Now we've said that this is going to be the init params, hidden size 1 hot, y equals 1 hot of y. For I in range, now we're going to loop. For I in range of our iterations, let's go back to the iterations. Where did we initialize iterations? Or are we just now, where did we, I don't remember initializing iterations. That must be something we're doing now. Okay, so for I in range iterations, Z1, A1, Z2, A2 is going to be for propagation given these parameters, weight, bias, and X. The derivatives of our parameters is going to be equal to the backwards propagation of this. This is, I feel like, kind of like saying the derivative of this is almost equal to like the integral. I don't know if that makes sense. But to go one forward is the same as to go one forward from 1 to get to 2 is the same as to go backwards 1 from 3 and get to 2. I feel like that's what this is saying. Weight 1, bias 1, weight 2, bias 2. Update the parameters given the derivatives and the original functions and the learning rate alpha. If I modulus 500 is equal to 0, then we'll print the iteration. Yeah, so see, here's the difference. He's going every 500 and printing a prediction. And then he's going to return, okay, yeah, that's the difference. He's going every 500. I think Samson went like every 10. I think Samson went like every 10 iterations. Oh, he went every 50. And yeah, he went every 50 and then printed out the iteration and the accuracy. He's going every 500, which only means he's getting what? There's 2,000. He's only getting like 4 accuracy predictions. Quite interesting. Quite interesting. Okay, and then oh, and then here's the evaluation of the model. Word propagation predictions equals get predictions. Oh, this is him just specifying like how the format. The format. Oh, so he wants the predictions of the model. He wants shape, and he also wants accuracy from the validation, and he also wants accuracy from the test. So predictions 231,319, da 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 da. Test 281,319,7004. So it messed up on. It predicted 3 when it was supposed to be an 8. And on the validation, it was 91%, 91.3%, and on the test, which would be that middle part of the data set. What was the training then? Did he print out training? Or no? He didn't print out the accuracy of the training model? Could we do that? I kind of want to see what the accuracy is, like when it was trained. What is it? Yeah. Because then I can, like, given the exam analogy, if you get like 100, or let's say the model gets like a 95 on the training set, and the training data set was the first half, so it was like easy, it was zeros and ones and twos maybe, or really distinct characters, whatever. And then you go to do the test, and the test is like what was the test? The test is the middle. So let's say you go to the dev validation. Let's say that was the end. So of course the end of a test is typically harder, so you expect it to go down. And then the testing, which is going to be in the middle, should be basically an average of the dev and the training set. So I want to see what the training accuracy was. So I would probably print, I'd probably put something in here to also do a print of the training accuracy. Accuracy. Now this means I have to go make code for this. So, which is simple. It should just be oof. Ah, oof. Train. Oof. Accuracy would just be equal to evaluating the model at the same, what's it called? Only difference is this would be X, hello, train, and this would be Y train. I'd be interested to see, and maybe like we could find that these are just an average. Maybe not. But that's the code that I would run. I didn't even realize the code changed halfway through. You see that? Like the format? I didn't even notice that. This is written in code. This is written in the hand-drawn font family. Huh. Can I change it? Yeah, change it to the code. I like the code. It just looks better. I'd actually be interested to see if this would work. Should we test it before I leave? The only thing I didn't put is the actual Kaggle data set, which is fine. It's just gonna be this. And just go ahead and put that in there. Okay. Sure. Let's test it. Let's test it in a notebook. Actually, I think I already have a notebook for this. I don't know why I just did that. Right? I made one. Oh, this was something different, but it's fine. What is this? Oh, this is Yeah, whatever. Doesn't even matter. Yeah, I was trying to use this data set, but we can remove this. Let's add the data set. Is this it? I want to make sure it's the right one. It might not be the right one. It's fine. We'll just get it from here. Can I have some daylight, please? It's fine. Let's move. I'm getting overstimulated. Okay. It's fine. I think my notes should transfer over. Okay, good. And then let's go ahead and do this. Let's do this. Oh, I forgot about that too. I gotta get rid of these. Yeah, forgot about all that. Can I get rid of this output too, or no? Okay, sure. This should all be one. Okay. I just want to see if this will give me the training accuracy. Literally, that's the only thing I care about. And I want to see if there's any correlation between like the training accuracy and what the dev and the tests were. Because this should have been that should have been a and what's it called? What line was that on? Transpose layers does not match the ending parentheses. Yeah, what line? Oh, line 15. Oh, very early. Am I slow? Oh, it's right there in my face. Okay. On it. There could be more errors like that. Yeah, I freaking knew it. So then just... Oh, do I need to have it in my... Okay, let me take this. Um... Hold on, I might have to do this and have this be equal to that. Oof. Whoa, 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 whoa. I need to get this to be data. This is path for sure, but so then, oh, I don't want the training data though. This is not going well yet. I still need to read it, but wait, hold on. Get this out of here. Digit recognizer is ready to use. Where's the... Ugh, can you tell I don't use Kaggle? Okay. Boy. Is this it? I can't remember. Because who did it by? By Kaggle. Should I take this too or no? Because I didn't print it. This may not work. Oh, I have to create a parser. I feel like this is a lot easier if I just take this, put that there, this here, and then that way I don't have to worry about a... I can just kind of go. Correct or incorrect? Oh, mother trucker, brother. Okay. Oh my gosh, data equals pd dot read csv. This, what's the issue, brother? Is it not? Alright, at least we're not getting that error anymore. New errors. New errors. Line 89. That's most likely a user error. Alright. Okay, wait. I don't think it's this anymore. Now it's whatever line this is. Weight 1 bias 1, weight 2 bias 2, X train, Y train, 0 0.1, 501, 0 0.0111. What's wrong with this line? Return weight 1. Wait. I don't think that's the issue. A value error? Are you sure there's an error? Let me try using the train set because Let me cook. Let me cook. What did he just say? What the frick? Train. Let me cook. What time is it? Love being late. I don't think. So something's wrong with this line. Got it. Something's wrong with this line. Got it. Something's wrong with this line. 58, 101, 89, 44. What the frick is 44 doing? I never remember typing in define a min or a max. What are they talking about? Oh, I love this. This is so great. I love this. All right. That's gonna be something for us to what do you mean? I'll figure it out. But I have to go. But I'll figure it out. I don't think it's. I think it's fine. I'll figure it out. All right.